What is the SAS congruence rule? The side-angle side, or SAS congruence rule, states that if two sides and the included angle of one triangle are equal to the corresponding sides and the included angle of another triangle, then the two triangles are congruent. Let's place the SAS congruence rule in one of our rule boxes and save it for later. The side-angle side, or SAS case, looks like this. You can use any angle with its connected sides for the SAS rule to work. The important part is that the sides must be connected to the same angle. To ensure congruency, the corresponding angles and their included sides must be equal. So why does the SAS rule work? Let's begin with one of the angles and the two line segments that span the angle. With this starting point, you can create any triangle in the world, so you need some constraints. The rule says that if you determine the length of the two line segments and lock in the measure of the angle, then all will be good. Say one side is of length 3 and the other 4. Well, you still have infinitely many triangles to choose from, so it's not enough. But if you now decide that this angle will be 81 degrees, then the opposite side of the angle is fixed, and the triangle is determined. This is just an example of the general idea, but it does give some insight into why the SAS rule works. These congruence criteria are actually pretty cool. Let's look at an example. These two triangles appear to be the same size and shape, meaning they're congruent. Let's find out if you have enough information to state this as a fact. In both triangles, you have information about the corresponding angles and the two corresponding connecting sides in the two triangles. This is a side-angle side case, and the SAS congruency rule can be applied. If it turns out that the corresponding sides and angles in the two triangles are equal, then the triangles are congruent. So, let's find out. The first side in both triangles has a length of 17, so those sides are equal. The included angle in both triangles is 23 degrees, so these are also equal. Finally, the remaining side in both triangles has a length of 13, so they are also equal. According to the SAS congruency rule, the two triangles must be congruent. So, despite knowing nothing about the length of the third side or the remaining two angles, the SAS congruency rule helps you conclude the two triangles are congruent in this case. Let's look at a final example. These triangles also look congruent. Let's see if you can use the SAS congruency rule to confirm this. In triangle ABC, you've been given information on two sides and their included angle. In triangle DEF, this is not the case. You've gotten information about two of the triangle's sides and an angle, but it's not an included angle. That means you can't use the SAS congruency rule. Be aware that these two triangles may still be congruent. It's just that you cannot apply the SAS rule. You may still be able to use one of the other rules to determine congruence. According to the SAS congruency rule, if two sides and the included angle of one triangle are equal to the corresponding sides and the included angle of another triangle, then the two triangles are congruent.